let's see if this is actually working. All right, cool. So I've been trying to get this working for a while, so I'm glad it actually is. Okay, give the noble gas shorthand for the following. Iodine. So if we're looking at iodine, the first noble gas before that is going to be Kr. And then we're going to say that's 5s2, 4d10. And then let's see, iodine 1, 2, 3, 4, 5. So that's going to be back up to 5p5. Don't forget when you do the d orbital, it's the period -1. The f orbital is the period -2. Okay, so phosphorus. Phosphorus, the one that comes before that is neon. And then we're going to say neon 3s2, 3p3. Chromium. Now don't forget, chromium is one of these special ones. I'll even change the color for that. Something different. I don't know. It's the same color that I'm doing. Okay. So chromium, we're going to look back at argon, and that's going to be 4s1, 3d5. And it takes one electron from here to fill the d orbital. So you would imagine it would normally be 4s2, 3d4, but it takes this and moves it over to down to the d orbital. So this is your correct answer right here. All right, so for copper, another one of the exceptions. Copper is going to follow pretty much the same rule here. It's going to be argon 4s1, 3d10. It's normally 4s2, 3d9, but again, we're going to take one from the higher energy orbital and move it down to the lower energy orbital. All right, and lead-2. Okay, so that's the same thing as saying Pb2+. So our normal orbital, this is the way I approach it if I don't know what exactly is going to happen. I'll go xe, and then I know it's going to be 6s2, and then now we have to go into the F block. So 4f14, then 5d10, and then 6p2. Now what ends up happening here is, since this is the normal orbital for lead, so let's get rid of that part right here. Lead is like this, so if we're talking about lead 2+, we need to take away 2 electrons. And we are going to be taking the 2 electrons away from the highest orbital. So our normal is 6s2, 4f14, 5d10, and normally we have 6p2, but when we come down here, we're going to take both of those away. So it's not going to have a p orbital anymore. It's just going to stop right there. Remember, if it's positive, that means it's lost electrons. If it's negative, that means it gained electrons. Yeah, just make sure you remember the special ones. So chromium, and then the precious metals. So copper, silver, and gold. All right, so the next little bit of information I wanted to cover is naming. Let's name the following. All right, so PCl3, we're going to go ahead and look at the periodic table, and we're going to pay attention to the location of the ladder. It just so happens that this one, everything is on this side of the ladder, so it's most likely going to end up being a molecular compound. If half of it came from this side and then half of it came from the other side, such as these ones here, And those are kind of a little bit of special cases because of the fact that they have polyatomics. Those are going to be ionic. Anyways, so with molecular, we're going to use the prefixes, such as mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So this is 1 through 10 for your prefixes. So you don't put the mono on the first thing because the only time you're going to put a prefix is if it's more than something. So we're going to say phosphorus, R-O-U-S, and since there's a 3 here, that's going to be the 3, trichlor, and then instead of saying trichlorine, you do just like you would do if you're talking about like sodium chloride, potassium bromide. You're going to go IDE. So this one would be phosphorus trichloride. All right, so this bad boy here is actually not something we're going to name as a molecular, even though if you look, hydrogen technically can be over there with the nonmetals. So we're going to go ahead, we would normally go ahead and name it as if it was using these prefixes, but in this case, it's actually something special. It's one of the polyatomic ions. And this is actually the only, well, besides hydronium, the only cation. So this one is actually ammonium. And that's different from ammonia. Ammonia doesn't have a charge, and that's actually NH3. So ammonia. Yeah, ammonium is the one with the positive charge. Ammonia is just NH3, it has no charge. But this is a polyatomic. All right, so then if I'm going for the next part, or you know, before I erase this, I'm sorry. Like I've told you guys, these videos are super informal. So I'm gonna look through these and see if there's any more that I'm gonna name with these prefixes right here. So nope, that's ionic, right? Because we have lead and then we also have a polyatomic. This is ionic, this is a metal and non-metal. This is ionic, this is the metal and a polyatomic, metal, polyatomic, metal, polyatomic. This is a non-metal and non-metal. So we're going to go ahead and name this this way, the same way that we named phosphorus trichloride. So there's one carbon, so we'll just put carbon. And then so 1, 2, 3, 4 tetrachloride. And my brush size is really large right there. Okay. Yeah, so carbon tetrachloride. The tetra comes from here. Remember, instead of putting tetrachlorine, we're going to put tetrachloride. Okay, so now that that is out of the way, let me clear this. Because for those of you that are mathematically inclined, I'm going to show you something to be able to tell the charges. Because if you remember, if you're talking about a transitional metal, it can have multiple charges. So we want to make sure that we specify what we're talking about. So in this case, lead can have 2+ or 4+. Those are the main charges that you guys deal with. This is plumbic, this is plumbus, for those of you that know that. If you don't worry about it. Okay, so whoops. So we know that nitrate is NO3-, right? NO3-. and there's 4 of them. So that means that this has to have a positive 4 charge. But for the people that are a little more into figuring it out the math way, we know whatever the charge for lead is, and this brush size is killing me. Whatever the charge for lead is plus 4 times NO3 is going to equal 0, right? This compound has no charge. Well, we know NO3 is -1, so Pb plus 4 times -1 equals 0, and that would mean that Pb equals 4 plus. So if we know the charge on lead is +4, if we were to name this, it would be lead 4 nitrate. And then so remember, when you're naming polyatomics, you just put the name of the polyatomic, nothing special there. But when you're doing the transition metals, if it has more than one charge, you want to specify what charge you're talking about. So going back to the if it has more than one, zinc is one of the ones that only has one, right? Remember, we have that little stepping ladder where we have aluminum, zinc, silver, and this is +1, and then this is 2 plus, and then this is 3 plus, and those are the only charges that they do. This will actually follow right here. Cadmium has a 2 plus, and then gallium and indium also have 3 pluses. But that's beside the fact. We're looking at this right here, so we know that zinc is 2 plus, and then chlorine is minus, but we have 2 of them, so it balances out. So if I was to name this one, I would just name it zinc chloride, not zinc 2, right? Because it only does a 1 charge. So zinc chloride, that's it. Okay, so I hope that noise wasn't too loud for you guys. I accidentally hit my desk with my knee. Okay, so CO, that's cobalt. So let's start right there. Cobalt. Anybody know what CO3 is? Yep, that's right. It looks like this, and it's carbonate. So carbonate. And then this is a transition metal, so we know we need to name, or we need to put something there for a charge. I believe cobalt can do 2 plus and 3 plus. You can double check me on that if you care to. But so, okay, cobalt, carbonate. So if there's only one cobalt and there's only one carbonate, we can just take the charge from carbonate and assume that that's what the positive charge is going to be on cobalt. So this one's actually just going to be cobalt 2 carbonate. If you want to use this trick right here, you can go CO plus, since we know the charge, I'm just going to plug it in, -2 equals 0. So we know that CO is going to equal 2 plus, right? Because you just add that to the other side. But yeah, so that's how you would do that one if you wanted to use the math trick. And I'll see what I can do to show you guys tonight. Well, it's not Tuesday yet. In lab is what I'm trying to say. Okay, so this, anybody know what that is? Yep, it's gold. So we'll start with gold. And then we've done this a couple times, right? That's nitrate. And gold isn't part of the stepping ladder. Gold can actually form plus and 3 plus for the charges. So it's going to be either gold 1 or gold 2. Just to stick with because the math thing that I showed you guys right here and over here, that's actually it's foolproof. Like, you can't mess it up. So as long as you do the math correctly, like you'll always get the right charge. So, all right, so AU plus, in this case, we know nitrate is -1 is going to equal 0. So in this case, we're dealing with lead 1. Or, not lead. I don't know why I said that. Gold 1. So it's just going to be gold 1 nitrate. All right. Coming over here to Cu2SO4. So you may or may not know, but copper can do 2 different charges. You have copper 1 or copper 2. What is this? She said sulfate, you're correct. And sulfate is SO4 2-. So, with that being said, let's use a little math trick. Let me actually clear some space. All right. And Okay. So we know it's going to be copper something sulfate. So just by looking, do you guys think it's going to be copper 1 or copper 2? Let's do the math and find out. So we know 2 times copper, right? Because this 2 is here. Don't forget about this. If you have a 2 next to the one that you're trying to figure out, you need to bring it into the front because you need 2 of whatever that charge is. Plus sulfate. So sulfate is going to be a -2 charge, and that's going to equal 0. So 2Cu equals +2, right? Just added that to the other side. Divide by 2, divide by 2. That tells you that Cu has a +1 charge. So that's going to be copper 1 sulfate. All right. Continuing on. Let's clear some room right here for this last part. Okay. So we have Hg2. We have 3 of those. And PO4, 2 of those. Okay. So if you know that PO4 is phosphate and the Hg is mercury. So mercury can form 2 charges. It can form +1 or 2+. So in order to figure this out, we know phosphate has a 3- charge. So we're going to say 6Hg plus 2 times -3 equals 0. The reason I say 6 is because you have 3 of the 2, right? So 3 times 2 is 6. So that'll tell you that 6Hg plus plus -6 equals 0, which will let you know you'll have 6Hg +6, so that'll tell you that Hg is +1. You can double check the math, but I'm pretty sure. So yeah, this ends up being mercury 1 phosphate. Okay. And there is another question right here for you guys. Yeah, okay. Name all diatomic elements. So I put this on here just to show you guys a little trick. So there is 7 diatomics. And then, so you should know diatomics are elements that aren't found by themselves in the, I don't want to say in the wild. We're not talking about Pokemon here. Um, so they're not found naturally. So something like you're not going to find I by itself in the wild. It's going to be found as in the wild. God, I said it again. You're not going to find I by itself in nature. It's going to be found as I2. So this question's asking, there's 7 diatomic elements. What are they, basically? So if you look at the periodic table, it forms a 7 on the periodic table, all the diatomics. 1, 2, 3, 4, 5, 6. So you have fluorine, that's going to be your corner, and then O, N, and then Cl, Br, I. Now it forms a 7, but if you count this, there's only 6, so you need to add one more, and that is going to be hydrogen. So again, if you look at the periodic table, the diatomic elements are going to be, you can look right there, so pay attention to right at the corner, the top of the halogens. You can go over 2, so your 7 diatomics are N2, O2, F2, Cl2, Br2, that's a 2, I2, and that's only 6 of them, right? So we need one more, and that would be hydrogen, H2. There's another one that people use. I just prefer this because it lets me know how many there are, and they're all really close to each other. So the other one people use though is Hofbrinkel. And then so you don't pay attention to the Hofbrinkel or the E on Hofbrinkel, and then that'll tell you H2, O2, F2, Br2, I2, N2, and Cl2. I don't like this one because it moves them all out of order. But you know, whatever works for you. The other one that I actually do like, but I'm so stuck on this 7 thing, is have no fear of ice, cold. This is where you get the Cl from beer. And this is where you get the Br from. So again, H2, N2, F2, O2, I2, Cl2, Br2. 1, 2, 3, 4, 5, 6, 7. This is easy to remember, but you have to remember for the cold and beer, you take the C and L and then the Br. So that's, you know, just something to keep in mind. I spent way too long on that. All right, so here we go. This is the last part of this one. So we have this molecule. No idea what it's called. I could name it if I wanted, but let's keep the video kind of short. And then I look at the time, it's like 24 minutes. So let's keep the video relatively short. So what I'm asking in this question is the shapes in relation to each of these. And that should actually not be like that. So this one's asking what the electron geometry is, what the molecular geometry, and what the approximate angle is. So approximate. And then this is using that table that he gave you guys. This is the stuff you would figure out. So we're going to look at this first, this carbon. So if we single this carbon out, it's going to look, I guess I should probably do it in the color that it's in. You'll have a C with a double bond. And then you have another C right here. I'm only going to draw what's next to it. I'm not going to go too far into it. So if we're looking at this guy right here, which is this one right here, obviously because they're colored about the same, how many electron groups does it have? You said 3, you're correct. How many of them are bonding? You said 3, you're correct. That's a really bad 3. Anyways, so it has 3 electron groups, 3 bonding groups, no lone pairs. It's actually, so the electron geometry is going to be trigonal planar. And that means that it's, if you turn it sideways, it'll be flat. And so your angle here is going to be 120 degrees. So from here to here, from here to here, from here to here, all 120 degrees. Now, it's going to stick with the parent molecule when you're looking at the molecular geometry because there's no lone pairs. If you had lone pairs, that's when your molecular geometry tends to pull away from your electron geometry. Your electron geometry can just always be seen as the parent group. And if you haven't came to the sessions, that probably isn't going to make that much sense. And just ask me about it when you see me. Again, for time's sake. So there's no lone pair in this, so it's actually going to be trigonal planar, just like the electron geometry. Okay, so moving on to the next one then. Let's clear this and go back to where we were. 2, 3 is good. Okay, so now we're going to look at this nitrogen right here. So we have nitrogen, we have hydrogen, hydrogen, and a carbon. So if we're looking, it has how many electron groups? 1, 2, 3, 4. And 3 of them are bonding, right? And we have 1 lone pair. So for electron geometry, if it has 4 electron groups, it's going to be tetrahedral, which should help you guys with your naming as well, because where does this part come from right here? If you said the number 4 in the prefixes, you're right. If you didn't, don't worry. Not much. So, okay, so if you're talking about the molecular geometry, so since there's not 4 bonding groups, you're not going to have the same as your molecular is not going to be the same as your electron. And we have 1 lone pair right here. So if you go from tetrahedral, you remove 1 atom, that'll give you trigonal pyramidal. Sorry if you can't read that. And then you take 1 more away and you get bent. They're all their angles are going to be about 109.5. But the more lone pairs you have, it's going to be, it's going to be less than 109.5. And you can just say this for everything that isn't a tetrahedral but has a tetrahedral for electron geometry. So trigonal pyramidal is going to be less than 109.5, and bent is going to be less than 109.5. So the molecular geometry of that nitrogen is going to be, because of the one lone pair, trigonal or trigonal, however you say it, pyramidal. All right. And the last one after a 30-minute video. I am so sorry, guys. I was gonna break this up into multiple videos, but I don't know, it's 10:45 and I just got this to work. And I'm still finishing up your guys' tests. So, okay. We're looking at this guy down here, right? This oxygen. That's one, that. Okay. So if we're looking at it, we have 4 electron groups, right? 1, 2, 3, 4. For bonding groups, we have 2, right? And then we have 2 lone pair. So, whoops, that's not the one I want to do just. Okay, so since we have 4 electron groups, we know it's going to be tetrahedral. And remember, the tetra is the same, that means 4. That means there's 4 electron groups around the central atom. This is going to be the same as water, right? Water looks like this when you draw the Lewis structure. So the angle from this hydrogen to this hydrogen is less than 109.5. From this hydrogen to this pair of electrons, less than 109.5. Well, this is the same thing, you just have different stuff. So here to here, less than 109.5. From the carbon to this electrons, the same as this. Okay, anyways, so we have 2 lone pairs. So it goes from tetrahedral, which is what I referred to as the parent group. Take 1 away, you get trigonal, pyramidal, oops, IDAL. Take 1 away again, you get bent. And that's what your molecular geometry is going to end up being. And like I said before, it's going to take on the same characteristic as the parent group. So 109.5 degrees. And if you guys need more explaining on that whole thing that I was doing with the parent groups, just again, let me know, ask me a question, all right? Yeah, sorry I'm getting this out so late. It's been a busy weekend, and I hope this helps at least a little bit. I'll see you guys tomorrow.